Question 4 is also coming from Quadratics. A line has the equation, this one, and the curve has this equation where k is a constant. Find a set of values of k for which the line and the curve have two distinct points of intersection. So first of all, we shall say for intersection, we solve these two simultaneously. So I'll get this y here and then I substitute it here. So I'll have x squared plus kx plus 6. This one is going to be equal to 3x then plus k. When I bring everything this side, I'm supposed to get a quadratic equation that comes from these two. So that will be kx, then minus the 3x, then there is 6, then minus the k, which is equal to 0. So I can simplify it and I say x squared plus, the coefficient of x here is going to be k minus 3. Factorize out the x, then plus 6 minus k, which is equal to 0. And then for two distinct points of intersection, distinct points of intersection, we know that b squared minus 4ac has to be greater than 0. Why is it like that? Remember, for any quadratic equation, to solve it, we are using this quadratic formula. X is equal to minus b plus or minus to the root of b squared minus 4ac out of 2a. So this discriminant here in the square root is the one that determines the nature of the roots. So if this one is equal to 0, we are going to get one point of intersection, which is going to be this minus 2b over 2a. All right, because this one has disappeared. And then if this one is greater than 0, that means we shall be in position to get the square root here. And then when we are solving, we shall take the plus, and then for the next root, we shall get the minus. So those are the two distinct roots. And if this one is less than 0, then you are not going to have a square root. The calculator will give you math error. So we don't have real values there, but instead we have complex roots. You see that? So since there are two distinct points of intersection, that means this one, when I'm solving this one here, I'll get the b squared minus 4ac, and it is going to be a positive. So that's why we are saying b squared minus 4ac has to be greater than 0. Are we together? Now our b is k minus 3. So I square it, then minus 4. Our a is a 1. Then our c is 6 minus k. So greater than 0. Then we can open the brackets here. This will be k squared minus 6k, then plus 9. 4 times 6, that will be 24. Negative 4 times negative k, that one will give us a positive 4k greater than 0. So simplified will be k squared minus 6 plus 4, that one will give us minus 2k. And then 9 minus 24, that one will give us negative 15. And then this will be greater than 0. Now this is a quadratic equation, okay? A quadratic equation in k. That means it is going to be a U-shaped curve, okay? We can actually factorize this one here. We have negative 15. Two numbers, when I multiply them and they give me negative 15, these ones are going to be 3 and 5. One of them has to be a negative because this one is a negative. And that will be negative 5. Because when I add these two, then I will be in position to get negative 2 here. Now that means this one will be k plus 3 and then k minus 5. Now, a common mistake done here is to get this one. People do this, k plus 3, then they say greater than 0. And also k minus 5 greater than 0. The way we solve quadratic equations, that you get this and then you equate to the 0 if here we have equal signs. So this one is wrong. You don't do that. What you do is to get the critical values because these are regions. So the critical values are going to be when you get this one and equate it to 0, this one will give you negative 3. And also when you get this one and equate it to 0, you will get the positive 5. Now we are supposed to look at the region less than the negative 3 in between the -3 and 5, and then above the 5. When we sketch this one, because the coefficient of k squared here is a positive, it is going to be a U-shaped curve. And then where it is going to cut the k-axis, this one will be the k-axis because it is in terms of k, right? Don't write x. Now we shall have a -3 here. That is where it cuts this axis. Now this one is positive because this graph is above this axis, and also this one is positive. For any value you are going to get for k here, this one will continue to be rising like that, okay? Then, of course, in between these two, we are seeing that the curve is below the k-axis, so this one is a minus. Now we are looking for the regions which are greater than 0, okay, where this graph is above the k-axis. So it is here and then here. Then we conclude and we say that k has to be less than the smaller one, and also k has to be greater than the bigger one. So k less than -3 and then k greater than 5. That is the set of values for which the line and the curve have two distinct points of intersection.